Welcome back to Worth the Effort Woodworking. In a previous video I did on harvesting, processing, and drying free lumber for use in a small shop, I kind of, as I was editing it, I didn't feel I was giving professional lumber mills a fair shake. I mean, admittedly, I'm a hack. I'm just grabbing, scavenging wood wherever I can find it and using drying processes that work for me based upon the knowledge I've gained through research and stuff like that. I don't have a formal education on this one. I'm not doing millions of board feet a year. So even before I published that, I started reaching out to several lumber mills to see if I could question them more on the professional side. What these guys are doing to give us the lumber that we use all the time, and what's good and bad and stuff like that. And Brandon Berdoll, who lives in the same area I do, he was kind enough to say, hey, yeah, come on now. I'll do the best I can to answer your questions. And if you're not familiar with Berdoll Saw Mill, I mean, he started about 10 years ago, and let me tell you, he's doing this right. It is truly a kind of a beginning family-oriented business. I mean, he has his house on the same property. If you follow his Instagram account, I'll put a link down below. I mean, all the time you see his kids coming around after school. They're still too young to do actually any good work, but he's getting them involved. And more importantly, he's doing processes that get you the quality of material that's just not common in the industry. I mean, I'm really grateful that he's going to allow us to do this. And plus the fact that he's very involved in our local amateur woodworking clubs and stuff like that. And he enters into some professional contests like the Kerrville Arts Market League or whatever, arts competition towards the end of every year. Just great furniture. I think he even won it or placed second one year. So really knowledgeable, not only on the processing of the lumber, but actually using it, which is what we enjoy doing. So today, let's get some questions answered on how the pros actually process the lumber. Hey, Brandon, thanks for letting us come out, answering some questions, bug you a little bit. I probably won't try not to take too much of your time.
It's all right.
Now, as I said earlier in the video, I did a little video on drying in my own shop. And basically, I've got a chainsaw. I cut stuff up to the sizes I can pick things up, throw it in the back of my truck, and take it back to my shop. And it's kind of a hack job of drying. It takes me forever, but it gets the job done.
Sure.
People like you do hundreds of thousands of board feet a year. I imagine there's different categories of sawmills and stuff like that. Can you kind of explain to everybody the different types?
Sure. So I think the two main things, there's stationary band saws and there's portable sawmills, or stationary mills.
Makes sense.
In the portable sawmills, you have a chainsaw sawmill, which the advantage of that is pretty low cost. You can start sawing up trees with a relatively low amount of initial investment, and you can also cut really wide material. They make them where they'll cut up to about 7 feet wide. So that's a huge advantage of chainsaw sawmills. The other category of portable sawmills are portable bandsaw sawmills. Like Wood Miser is a very popular brand.
Yeah, I've heard that.
It's on a trailer package. You can tow that out to a site. You can saw trees off-site and mill up lumber. So that's another great.
That kind of what Matt Cremona did. He just kind of built his own, just a big size one.
He did, but it's stationary, so it's not on a trailer axle or something. Yes, you have to bring the logs to the mill.
Okay, that makes sense.
So, and then you have stationary mills. And so in stationary mills, you typically have band saws or circle mills. So
circle mills?
Circle mills, yeah. So they typically run a lot of different size circle saw blades, but from about 48 to 60 inches is a pretty common size of blade. And so the log.
Is that kind of Johnny Cash one where he was in the movie?
Yes.
Oh, okay.
Yes. Not a real accurate portrayal of that, but
okay.
Yes. Yeah. So the blade is turning, and the log is fed past the blade, saws a board. You bring the log back, saws another board. They have mills that have double blades. There's a blade on the bottom and there's a blade on top, and they're just offset from each other just a little bit, and you can feed them through there. They can cut up to, I think, about 36 or maybe 40 inches wide. The advantage of those mills, you can cut really fast, and you can cut really straight lumber because you have a really thick saw small that doesn't want to weigh very much. So it's pretty, I mean, you can cut 20 or 30,000 feet a day with a high horsepower circle mill pretty easily.
And is that mainly softwood, like timber framing kind of stuff, or sticks that we build houses? Is that what they use that one for?
It can vary. It's the curve takes out about 1/4 of an inch, so it's typically on woods that are not quite as valuable. So it's lower price point pine, and if you're cutting maybe like railroad ties or something like that, where you're not making a lot of cuts. Now there still are mills that run a circle mill cutting hardwoods, but when you get into the walnut and cherry and maple and stuff, you really want to conserve as much wood as you can. So you typically go to a band mill to reduce the kerf or reduce the amount of sawdust. So you have circle mills that are in the stationary bandsaw category, and you also have stationary bandsaw sawmills. So these are mills that typically, they do not have some type of trailer or wheels underneath them. They are set on a solid foundation, and those are typically more high production saws. So even some of them even have teeth on both sides of the band, so they cut going and coming. And so they're really high productive mills are able to saw a log. The band is spinning, it's typically they're vertical, and the log passes, and when it comes back they move the log over and they saw it again. So what they're trying to maximize is what percentage of time the blade is actually in the log. And so they've come up with bandsaw blades that
can't imagine how they're bracing that blade if it's going back and forth.
There's really no brace on the backside. It's just on the sides, and it's under really high tension. Yes, and those bands can get up to 16 inches wide. So it's pretty common for 8, 10, 12 inch wide bands, but I know of some mills that run 16 inch wide bands. So
expensive. I wouldn't want to have to fold that one.
No, a lot of them are 30 to 40 feet long.
Oh,
so, yeah.
Okay, in our area, I've only really seen those, chainsaw mills and a few small Wood-Mizer bandsaw mills, and the ones you have out there that we'll show them later on. And you were mentioning those circular saw mills. They're obviously able to produce a lot more material, but in Texas, we don't really have a milling industry other than, pines out in East Texas.
Sure.
Is it going to be different in different parts of the country?
Sure. You get where there is true forest or timber. The timber is really good quality. Up in the Northeast, like Pennsylvania, is a really good area. The timber grows tall, straight, clear, and there's just a lot of it to be harvested. So you see really high production sawmills in areas where the forest can produce that much timber. So in our area, if you were to set up a mill, you would exhaust the resources in your area relatively fast.
Yeah.
So you have to be in an area that the timber grows where it's lots of trees, big trees, and close together that produces good lumber.
Okay. Is there an advantage to having the big mill versus just a little chainsaw, or those Wood-Mizers that can only do about 2 feet of material?
Well, we need to define big mill. So there's a difference. A big mill can be a mill that will cut wide or big logs, and a big mill could also mean a mill that cuts a lot of volume. So
okay, for now, let's talk about wide, big logs.
Sure. Natural edge slabs are really popular right now, and so big logs produce really wide natural edge slabs, and so that makes it an advantage to have a mill that will cut really wide.
Okay.
I mean, the only thing is, like, if the logs are bigger, you typically clear lumber around the outside, because when the tree was a baby, it had limbs coming off, and the trees self-prune, the inner branches die out, and so once those inner branches die out and you have this trunk, then it starts putting on growth, and that growth is clear growth. It's free of knots and limbs that are broken off and stuff like that. So if you get a big log, you typically get higher grade lumber,
high quality straight grain,
out of the outside of the log. And as you get closer and closer towards the center, the grade or the quality usually goes down, because you encounter areas where limbs have fallen off in the past, and those are knots.
But typically wide mills aren't going to be cutting fast just because the blades are in the wood a long time?
Yeah, you can only push a band so hard, and so if you try to saw too fast in a big wide log, the blade will start to wave on you. So you just cannot cut 30, 40, 50 inch wide boards or slabs really quickly.
Okay. So that's always bugged me is up north, everyone talks about that they just drive down the street to a log mill. I mean, a log yard. Is that a real thing? Is that common up north?
So we don't have those in this part of the country around the central Texas area, but you get into the northeast around Pennsylvania where there's lots of timber.
The spoiled people?
The spoiled people, yes. Where the trees grow tall, straight, free of limbs for 40 or 50 feet.
What?
So, yeah. In those areas, they do have log yards or log concentration yards. And so that's an area to bring in logs from different sources. It can be from loggers or other things. And all the logs are concentrated in one area. And at that point, they can be sold off to veneer buyers. They can be sold off to sawmills. And so one person or one company typically owns this.
That's like a distributor of trees?
Sure. Yeah. They bring logs in and they sell them. They might have an auction for veneer logs. So Friday they might be auctioning off a lot of cherry logs. And so veneer buyers might come in from all over the world to purchase certain logs. They're tagged.
Okay, you said veneer buyers. What's the difference?
So veneer buyers are looking for a certain grade of log. They're wanting logs that are free of limbs on the outside. So they want the bark to be clear, and they have a lot of specifications. They're very, very picky about what they purchase because the quality of the veneer is really, really high. So they're a trained person that has been taught how to look at logs, evaluate logs, the texture of it, the color, the amount of growth rings, and they're really study each log and purchase a log to make the best veneer possible.
So somebody like me going up to, if I were to drive up there saying I want to buy a few logs, veneer quality is probably going to be out of my price range, or is it just not worthwhile to buy that kind of stuff if all you're doing is making 4 to 8 foot boards? Is it worthwhile to ask for veneer logs?
It depends on your budget and it depends on the quality. You can get quality lumber out of logs that are not veneer logs. You might not get as much, but you can definitely get usable lumber from a log that would not grade as a veneer log.
I know margins are kind of small. Is it worthwhile for somebody like you in Texas to drive up there to get these kind of logs?
We typically try to stay within a 100-mile radius of our mill. So if we start hauling timber more than 100 miles, it really eats into the profit. Unless it is a really, really big log. If it was, say, 4 or 5 feet in diameter, we would drive, maybe 200 miles to get a big log like that. But in general, we need to stay with less than 100 miles to make it worthwhile.
And is that kind of the same way pretty much everywhere, especially in the high volumes? More volume, the smaller their margins are, so that's why the lumber mills are concentrated up there?
Sure. I'm not sure how far away they get their logs, but I suspect that it's not more than 100 miles. I would say most times it's probably within 30 to 60 miles.
Okay. Well, if you have a distributor for logs, is there another category right above that that's a wholesaler, or are they just going straight to the mills to cut up?
They would go straight to the mills to cut up.
Okay. Are most mills doing the rest of the process after that, or are they specializing in one aspect of it?
Some mills just specialize in sawing the lumber, and they sell the lumber green. So it comes off the sawmill, it gets stacked on a pallet, a solid pallet without stickers or anything, and it's sold within a day or two to a dry kiln. And other lumber mills mill the lumber, they put stickers in between the layers, and they dry them also. So some mills take that extra step to dry the lumber, and other mills prefer just to sell it green.
I do know you're somewhat vertically integrated because you got logs out there, and I can go buy lumber over here. Mm-hmm. So can we go see where you start out at?
Sure, let's go.
Okay.
I notice y'all have a lot more logs than you normally do. I imagine most lumber mills, kind of like you, are looking for specific stuff. Is there anything in particular you look for in a log?
Sure. The kind of first two things we're looking at is it has a centered pith. So let's look at this log right here. This is a pecan log that we got in. The pith is right here and it's centered in the log. So if this pith was way off to one side, that would indicate that the tree was leaning, and that would not make good quality
those leaning
furniture.
trees are the kind I always get because they're the ones that fall over. I'm scavenging for stuff, so
Sure.
I guess you're getting to pick the prime stuff.
The other thing that we're looking for in logs, we want a minimal amount of limbs on the outside of the log. So this log here has one limb there, but it's relatively small. It would be ideal if the bark was clear all the way down the whole log. That's really ideally what we're looking
Do you
for.
have an example of that?
There's a log right over here that we can take a look at. So this log here, it has a little bit of damage here from felling it, but all the way down the length, except for the last couple feet, is clear bark. So this is an ideal log for us. It has a centered pith, and it has 4 clear faces, we would call it. So a face is 1/4 of the log around. So if you exclude, we'll probably trim those limbs off. We'll trim the log to remove those limbs, and this log will have 4 clear faces and a centered pith, and that's ideally what we're looking for to cut high-grade lumber.
Well, I know some logs here look like they're a little bit older, and some look really, really freshly cut. Is there kind of age range that you like after it's been felled?
We prefer to cut them up as soon as possible. It's a little easier to saw, but sometimes we just don't get to the logs. They might sit out in the forest. They might have been dead for a while, and so some logs are already kind of aged when they come in, and we typically try to cut those relatively soon.
Are you cutting anything up right now?
We're actually cutting a 20-foot log today.
20 feet?
20 feet
You
long.
know it's big enough?
It is.
Can we go check it out?
Let's go.
Okay. Balance, great direction, stuff like that. As y'all saw stuff, you laying up there.
Most of the time we try to level the pith on the saw. So we try to have, if the pith is 30 inches off the saw deck on one end, we try to make it 30 inches on the other. That way we're sawing parallel with the pith. And the way we typically saw logs is we cut a few boards off the top of the log, we'll flip it over, cut a few boards off the bottom, and a few boards off of each side. And then once we have the log squared up, or a 4-sided cant, we're looking at each face of the cant, and we're trying to determine which face will produce the best board. Continue working your way around the log, and that produces mainly flat sawn lumber because you're working your way around the log.
You've been doing this for 10 years. Is this the first sawmill you started out with?
I actually started out with an Alaskan chainsaw sawmill. It has an 8-foot bar, and we custom made it to cut big logs.
Wow. So it looks to me like you're cutting 8/4 right now. Is that kind of industry standard, or is there a reason why you're not going a lot thicker? Because a lot of bowl turners and stuff like that, we really like the thicker logs to give the deeper bowls.
Sure, we're cutting these slabs about 3 inches thick right now, and we cut them at that thickness because it's taken us about 2 or 3 years to dry 3-inch thick slabs. And so if we cut them any thicker, it would take much, much longer to dry those slabs.
It's taking you 2 or 3 years, and you're still using a kiln. Is that kind of normal?
It really depends on the thickness of the material that's being cut. So for thin material, that is not typical. They can dry it much, much faster. But if you get into material 12/4 or 16/4, that's a pretty standard time to be able to dry lumber that thick.
Even with the kiln?
Correct. Vacuum kilns can dry it quicker than that. Some mills or some kilns have vacuum kilns, but that's a kiln that we don't utilize.
So right off of here, where's this log going?
So the slabs, once they're sawn on the mill, are going to be placed on a pallet with stickers in between the layers so it can begin to naturally air dry. Okay, we're going to take a look at a pile of lumber that's been stickered, and it's in the air drying stage. So this is a pallet of 4/4 pecan lumber. As you can see, we have really tight sticker spacings that makes the lumber dry flat. And these
What do you mean by stickering?
These stickers are kiln sticks that are in between each layer, and so that allows air to flow in between the layers, and the board is able to dry from the top and from the bottom.
I've heard of sticker staining. Is that a major problem for y'all?
It really depends on the species that you're sawing. Some species will sticker stain a lot worse than others. Pecan will do it, so we use a fluted kiln stick. That
What do you mean?
it has ridges, and so the wood only rests on the ridges. That allows air to flow underneath the stick, and it reduces the sticker stain.
Okay. And why are you bringing it in here into this warehouse?
If you have too much wind or you have too much dry weather, the wood will actually dry too fast and it will crack on the surface. It will have surface checks. So we're trying to minimize the airflow through the pile of lumber.
So the warehouse is just as a wind block. Is that pretty standard in the industry?
Depends on the species again. Some species you can dry outdoors, and other ones you need to keep, like oak is a species that typically is dried in sheds or at least with some wind break, because of too much airflow it will crack on you.
Well, I'm sorry, this thing is what, 30 feet high? You
Correct.
really need a warehouse that tall?
We stack the lumber as high as we can to put as much weight as possible, so the material on the bottom will dry really, really flat. Even with that, sometimes we have boards cupped that are on the very bottom layer.
So a stack that tall is still going to sometimes cup on you?
Occasionally, it doesn't happen very often, but every now and then you have an individual board that I think you could put the world on top of and it would still cup. Just the power of wood.
Is there any way to tell if it's going to cup ahead of time?
No,
Oh, crapshoot, huh?
that's right.
Okay. Well, after that initial air drying, we're going to the kilns. And, you know, my kiln in my shop, I've just got a defunct refrigerator. I put a light bulb in. The idea is I put it on my drying rack for 3-4 months, and then I put it into that cheap kiln. The idea of getting rid of that initial water was the idea. I'm looking over here. Your kiln has a lot more machinery attached to it. I even see a big, is that a water tank?
Correct.
On top? Is it basically the same principle, just raising the air temperature so that the moisture is?
Well, the differences are is we're monitoring the temperature, we're monitoring the relative humidity, we're monitoring the airflow, and we're also monitoring the moisture content inside of the board while it's inside of the kiln. So there's typically a set of pins that are driven into the board, and wires run outside of the kiln, and we can see as the board is drying what the moisture content is. This is the back side of one of the kilns, and as you can see here, this is a vent. So when the humidity gets too high in the kiln, these vents open up and it brings in cooler, drier air, and it exhausts the hot, humid air. The air that's humid, that humidity came from the board. So we're actually just drawing in cooler, drier air and then sending hot, humid air out.
Well, I know heat rises because in my my refrigerator, I put the intake vents on bottom and the heat things on top. Are something like this, I've always wondered, are the boards going to dry at different rates, just depends on where they are in the stack inside the kiln?
They're going to dry evenly because the airflow is even. And so the temperature might vary a little bit, but it's constantly being moved around. And so there cannot be a very big difference in the temperature from top to bottom because it's constantly being circulated.
Are you actually drying different size lumber in the kiln, or is it all going to be 8/4, 12/4, or is it mixed out?
We typically do not like to mix species or mix thicknesses, so we'll dry the same material and the same thickness that's been air dried for the same period of time in one kiln load.
Okay, so this kiln is like a shipping container. I assume it's not a shipping container, it's something built specific. How long is it going to be in there?
It depends on the thickness of the material, it depends on the species and how long it's been air dried, but it could be from as little as 20 or 30 days up to several months.
Okay. What would be the benefit of air drying it longer before you put it into the kiln?
One of the benefits is just reduced costs. So basically with air drying, you get free, the water is exiting the lumber for free without any extra fans or extra heat. So that's one thing. As far as the quality, it typically produces a little more stable lumber that is not quite as hard and not quite as brittle. So if you dry material too fast, it case hardens. And so when you go to rip it on a table saw, it moves, or if you try to plane off one side too much, it'll bow on you. Whereas if you air dry it first and then finish off in the kiln, it's usually a little bit, it doesn't move as you're working it.
Okay, harvesting and drying, I mean, harvesting it, cutting it up, yeah, that's kind of, I could do that one. Whenever I'm buying lumber for really good quality furniture, I'm going to the hardwood dealer, I'm basically paying for your expertise in drying. Is there a lot more that you could tell me about drying beyond just heating it up?
Sure, let's go talk about it.
Okay. Okay, that was kind of a lame transition just to get you back in this office, because really the art and science of this is the drying. That's where a lot of us are ignorant. I mean, I'm going to the hardwood dealer to buy my lumber. I'm assuming it's dried correctly, but it's kind of a crapshoot sometimes. So can you kind of tell me what the industry kind of standard is for drying? Maybe what you're doing a little bit different, or what some dealers can't, some dryers can do to get their product better than other people's.
Sure, I'd be happy to. So kind of industry standard is getting the moisture content from the green stage, which is usually about 60 to 80%. It can vary on species and logs, but down to between 6 and 8%. And during that period, from that green stage to dry stage, controlling the evaporation of water from the wood. And at any point, if it exceeds what the lumber can tolerate, it cracks. And
Okay,
so,
what do you mean it can tolerate over? Is it a speed of drying or a time of drying?
so wood is similar to steel. It has an elastic limit. You know, you can take a piece of steel and bend it a certain amount and it will spring back to the same shape.
Right.
But you bend it far enough and it's going to stay there. Wood is kind of the same way. It's elastic. So as it shrinks, as it dries, it shrinks. And if it shrinks too fast, it cracks. And so people that are drying wood really well are monitoring the drying process from green to dry, and they're not allowing the wood to dry too fast where you get honeycomb or you get surface checks and those things in it.
Well, I based my drying thing off of a little Oregon State pamphlet I read, and they were talking about free water and bound water, and I did a horrible example of explaining that. Can you do a better job than me explaining free and bound?
So if you break down the cell structure of a piece of wood, it's very similar to a soda straw that has a very thick wall.
Okay.
That's kind of it's a very basic term, but the water that's inside of the straw will be the free water. The water that's inside of the cell wall, so like the wall of
the plastic of the straw.
The plastic, yeah, that would be the bound water. And so the free water leaves very, very easily and very rapidly. It's the bound water that's chemically bonded to the cellulose that's difficult to get out. And so from green down to about 28 or 30%, the free water is leaving. And from that 28 or 30% moisture content down, that's when the bound water is actually leaving the cell walls.
Okay, you just said it was chemically bonded. It's not just osmosis letting it pass through. I mean, there's a binding aspect to it.
Sure. So wood it's made up of carbon, hydrogen, and oxygen. And so those hydrogen bonds, they want to bond to the carbon and the oxygen. So that's a really tight bond in the bound water.
I understand a little bit about that free water and bound water, but which one of them is really affecting the movement of wood?
The bound water is what actually makes the wood shrink or distort. The free water can leave and you don't actually see anything happening. A good analogy, I think, is a sponge. So you could completely saturate a sponge and it would be at some dimension. And then you could take your hand, you could squeeze that sponge, a lot of water would come out, you set it back on the counter or the table, and it would still be the same size as it was when it was full of water. But 2 or 3 days later, you come back and that sponge is dried up and it will have shrunk down. And so that's a good analogy. When you wring it out with your hand, that's free water leaving. And then from there on, the water that's in the sponge, when that leaves, the sponge actually shrinks down, very similar to a board.
Okay, so what's affecting that bound water coming out?
There's really 3 things that affect that, and it is the temperature, the relative humidity, and the airflow. So as the temperature goes up, you can evaporate more water from the surface of the board. As the relative humidity gets lower, you can evaporate more water, and as the airspeed across the top increases, you can increase the water. So it's a combination of all 3 of those things that allow you to evaporate bound water from a piece of lumber.
But all you're talking about is off of the surface of the lumber. That's just evaporation off the surface.
Correct.
What's affecting the speed of how that water is from the center of it? Because that's why I've always told that big logs take longer to dry, right?
So there's a gradient that gets built up. So as water evaporates from the surface, the moisture content of the fibers on the very surface, they're lower than the core. And so the water wants to migrate from the core out to the surface. And so the drier the outside is, the faster that water is going to move from the inside to the outside of the board, from what we call the core or to the shell.
Okay. Is causing that migration to go faster or slower, does that affect the final quality of the lumber I'm getting at the dealers?
Absolutely, yes. If that water is trying to leave that piece of wood too fast, it's going to crack. It will, in the initial stages of drying, it will produce surface checks.
Okay, that's stuff I can see when
Correct.
I'm buying something. But I've bought stuff where it looked perfect, especially the thicker stuff. And that's kind of what got me away from going to the hardwood dealers. Was I bought a perfectly good looking board, and then I cut into it, and all of a sudden those cracks are there, and it's worthless to me.
Yeah, that's called honeycomb. And so that is created when, in the initial stages of drying, at some point it was subjected to too high of temperatures, too low of relative humidity, or too much airflow, and the actual surface of the board cracked. And then in the later stages of drying, those cracks closed up on the very surface, maybe a 1/16 of an inch down, but under that there's still an open crack. It's very similar to if you take your hands, and this is what you see on the surface. You see a pretty board, and then you start planing down, or you resaw it, and you see these open cracks. It's called honeycomb, and at some point it was dried too quickly.
It sounds like a lot of stress is going on during that process. Can you explain that a little bit more?
Sure. So there's really 2 stresses in trees and lumber. There's growth stresses, so a tree that's been leaning on the side of the hill, It'll have tension on one side or maybe compression on the other.
And that causes the different thicknesses of the grain on each side.
Correct.
And where the pith is.
Mm-hmm. The other stresses are drying stresses. So as the outside of the board or the shell of the board dries and the inner portion, the core, has not dried yet, you get internal stresses. And so if you dry lumber too quickly, those stresses are a lot. I mean, they get to be a lot. And it's normal to have stresses in drying lumber. And the good mills and the good kilns that are doing it, they have a process at the end called conditioning, where they actually introduce moisture into the wood to relieve those stresses, and that's a really important process.
So that's a difference of a big kiln production professional guys and somebody like me. I'm not throwing steam at the end of my little kiln thing. So okay, that makes sense. And that will prevent a little bit of movement when I get the wood back to the shop.
Correct. If the lumber's been dried and has not been conditioned, then when you try to rip it on the table saw, it might pinch on you. Or if you try to plane one side of one face of the board is slightly more than the other face, it will bow on you. So just before the conditioning cycle, the inside of the core of the board is in tension and the outside of the shell is in compression. And so when you introduce lots of moisture to the outside, it equalizes those stresses. You can typically tell if lumber has been conditioned or if it has not been conditioned, how it moves when you try to work it.
Okay, let's pretend I don't remember any of that, and I'm going to maintain my ignorant status on drying. I'm going to a lumber mill. I don't want to waste my money. Is there anything I can do to guarantee that whatever I buy is actually going to behave properly when I get home?
The best thing you can do, in my opinion, is take a moisture meter with you. There are electronic moisture meters that you don't have to drive pins in. You can just set on the piece and make sure that the lumber is dry. I would recommend less than 10%. So if you put the moisture meter on it and it shows more than 10%, I would be cautious.
So if I buy a board, I take it home and I cut into it and it has honeycombing, or if I rip it on my table saw and it warps so much that I'm scared of kickback because it's going to hit the back of the blade or something like that, is it a fair assumption that the rest of the stack, that if I take it back and get it, I pull another board out of that same stack, that's going to be in the same situation?
Wood is so variable that I would say that it's a good chance that the rest of it might be fine. I mean, there are internal stresses in trees, growth stresses that vary from tree to tree. And so I would say that if you had one piece, that it would not be accurate to say the rest of it is going to be bad. Now, I think it's reasonable to have a board every now and then that does exhibit some behavior, because it's a natural product. You know, it's just something that was a living thing that we're trying to use and for our purposes. And so if that is occurring every once in a while, very rarely, I think that's acceptable. If it's occurring a lot, well, then there's something going on with the stresses in the tree or the drying stresses.
Okay. When I also go to the lumber mills and stuff like that, in a stack, somebody undoes a snap, so it came straight from the mill they're putting out there. Is it a fair assumption that most of that came from the same tree? I know when you stack it, you're doing the big stuff, so you can say that this all came from the same tree. But if I'm buying it from the lumber yard, from the hardwood dealer, I want to match color and stuff like that. Is that a fair assumption, or is that something I have to ask specifically for?
The only way you can typically get lumber from the same tree is a specialty mill. The big mills, the log is sawn up and it gets divided into different bins based on grade and width and length and color. And so I would say that a bundle of lumber, there's a good chance that none of it came from the same tree. Maybe might be a few boards here and there, but in order to get really matching grain and matching color, you have to typically go to a specialty mill that is a lot lower volume but can keep the logs together during the drying process.
Okay, is there anything that I'm so ignorant about this stuff that I just don't know to ask you, or the typical guy isn't doing, that you would really recommend?
My recommendation would be purchase a moisture meter, a good quality moisture meter, to monitor what's going on with the wood. And I think you'll learn a lot if you use one of those.
This is a Wagner meter that we use. So let's go to a slab and let's check it out. So this is a slab that was cut about 3 years ago. It's gone through the air drying process and the kiln drying process. We put the meter on there. It's reading 7.3, 7.4%. So right in between 6 and 8%, ideally like it should be. And you can see the slab doesn't have any surface checks. It doesn't have any honeycomb from top to bottom. So that's what I'd be looking for. I'd be using this meter to check the lumber as I pulled it out.
Okay, this is a flat sawn board.
Correct.
Okay, that's flat. I know most flat sawn boards are not flat when I'm buying it. I know you're a specialty mill, but why didn't that warp?
It did warp. It's just been surface flat after it warped. So there was some amount of distortion during the drying process, but we were able to surface this slab flat, and now it's flat.
Okay, so if I'm just going to a backyard lumber mill, okay, that's just not something I'm going to find because you did an added service here. So most lumber mills, it's not going to be that flat.
Correct. If you're buying rough sawn lumber, well, then you can expect some cup in the boards or some bowing in the boards. So if you're purchasing surface lumber, it should be reasonably flat.
It's going to be the same thing with the lumber as far as the slab, right?
Correct. So if I was purchasing some lumber, I would take my moisture meter, I'd place it on the board showing 5.2, 5.7, 5.8.
Yeah, is it really going to be different all the way across the board?
Well, it varies. These moisture meters are based on density. So we can look at this actual board right here. This is sapwood and this is heartwood. The heartwood is a little bit denser. So let's just see. It's reading 4.9 or 5.2 there. And we go into the heartwood and it's 6.7. So the moisture content really is not different from here to here. It's just the density of the wood. And so the sapwood is a little bit less dense than the heartwood on this particular board. So that's why you see that slight variation of a couple percentage points.
And that's why you're looking for a range instead of an exact number.
Correct.
Are the little pincher ones that poke into the board going to read differently, or are they still density?
They're based on the electricity flowing them, so they do have a species correction on those. So you have to set for the certain species that you're monitoring.
Sounds good. Thank you for all your time.
Thank you.
It's been a pleasure. I wasted about half your day, but hopefully they will benefit. And guys, how tall is that?
20 feet.
20 feet. We got some slabs here. So if you're interested in slabs or hardwood in Texas, hey, at least check out Berdoll's as thanks for him showing us a little information. And remember, it's always worth your effort to learn, create with all this stuff, and share it with others. Y'all be safe and have fun.